Right. Okay. Assalamualaikum and good afternoon, everyone. Okay, welcome back again, and thank you for still stay with us. So today, after this, the third session, we will continue with the next speakers, which is Professor Dr. Baba Musta, and I will briefly explain about his CV. And he's from Sabah, Malaysia, and he's graduate. He's degree at UKM in 1991, while master also in UKM in 1995, and PhD at UTM, University Technology Malaysia, in 2003. And he's expert in geochemistry and also environmental geotechnics. So without further ado, I would like to call upon Professor Dr. Musta to give his speech.
Bismillahirrahmanirrahim. Thank you very much, Dr. Nodiana, for the introduction. Somebody help me to click. Yep. Assalamualaikum warahmatullahi wabarakatuh. Very good afternoon. Selamat sore. Ya. Selamat siang. Okay. First slide. Yeah, okay. So the title of my presentation today will be on geochemistry of weighted ultrabasic from Ranau, Sabah, Malaysia. Okay, so yeah, before I go for the introduction, I just want to highlight. So we celebrate 25 years University Malaysia Sabah this year. 25, young, still younger compared to yeah. And also we promote the Eco Campus. See the logo there? I couldn't find the pointer. Can you help me? Okay, next slide please. Okay, so who interested to visit our place? So we are in the north of Borneo Island, dark green, yellow color there. University Malaysia Sabah, situated in the western part of Sabah. So we are far away from Peninsular Malaysia. It's about 20 minutes and 2 hours and 45 minutes by flight from Kuala Lumpur. So in one island we share 3 countries there. So we have Malaysia, Indonesia, and also Brunei Darussalam. Okay. The future capital of Indonesia also will be in the same island. Next slide, please. Yeah. Okay. So we promote Eco Campus. This is the panorama, the view of University Malaysia Sabah campus, and the upper left there, the roundabout on clock tower of University Malaysia Sabah. We have a Chancellor building, so we have a jetty also, and the bottom left there is a Faculty of Science and Sumber Alam, or Faculty of Science and Natural Resources. Okay. Oh, okay. Oh yeah. Oh. Okay. So you close here. Next slide, please. Okay, so my presentation, so this is the outline. Start with the introduction, the objective, the methodology, results and discussion, and also we'll conclude and give some recommendation. Okay, next. So for the introduction, so the study area situated in Ranau, Sabah. It's about 2 hours driving from the city center of Kota Kinabalu. It's about 106 kilometers. And why we choose Ranau as a study area? So this is we can see the good outcrop of ultrabasic from Ranau town to the main road to Sandakan, and also to the pouring area. So you can see so many outcrop there. And the other basic rocks were exposed to the surface due to the tectonic forces in the middle Miocene age, as reported from the previous researcher. And if you observe the outcrop, you can find also the low metamorphism serpentinite rock. So this is originated from the Ultrabasic. So for those who are not really familiar with Ultrabasic rock, so Ultrabasic rock is an igneous rock, dark in color, high abundances of mafic minerals, mostly pyroxene, olivine, and less silica, less than 45 SiO2 percentage of SiO2. Okay, next slide, please. So before we arrive in Ranau, it's about 7 kilometers. You can find there is a mountain Kinabalu. So Mount Kinabalu there. This is view before the earthquake in 2015. This is after the earthquake 2015. Okay, there is a slightly different in terms of the geomorphology pattern. Okay, next slide. My field of study more on the weathering process. So the weathering process in the rock will produce soil, and there is a different rate of weathering process based on different type of minerals or rock. And for the long-term process, there is a potential of a redistribution of elements or heavy metals from the rock into the environment. Okay, next slide. Okay, so for the weathering of the basic, you can see this is the process where the rock will change to soil or break apart to the small particle and produce secondary minerals. For example, the iron oxide minerals as well as clay minerals. Next. So the objectives of our study, basically one, to identify the distribution of ultrabasic rock in the Ranau area. Second, to study the geochemistry and also the mineralogy of ultrabasic rock, as well as the weathered ultrabasic rock, and last but not least, to map. To map the geochemical patterns of selected heavy metals from the study area, particularly in the lowland area where the villagers cultivate paddy for the agricultural activity. Okay, next. Okay, so as I mentioned just now, this is Malaysia and Peninsula, and this is the Borneo Island. So this is Sabah, and this is the study area in Ranau, Sabah. So this is the capital of Sabah, Kota Kinabalu. Okay, for the geological map of Sabah, different color, different types of rock there. But so we are interested only on the this ophiolite complex, where the ultrabasic rock or ultramafic rock is a part of the ophiolite complex. So we can find in ophiolite there is ultrabasic, there is a chute, there is spilite, and also there is some gabbroic rock. So so this is Ranau. So we can see here there is ultrabasic outcrop. It's very small pages there. Okay, the rest we can found at the basic some in Telopit, in the Dan Peninsula, and also in the Lahat Datu area. Alright, so if you can select one type of rock there, so this is the ophiolite. So this is the distribution of ophiolite rocks in Sabah. Now we go to more specific on the geological map and also the stratigraphic sequence of rock in this study area. Okay, so this is Ranau town. So this is the distribution of ultra basic rock. So there is also one ex-copper mine there, but it's closed in 2000, yeah, end of 2000. And this is the Mount Kinabalu. So we study this particular area. So there is a paddy field here. So this is the stratigraphic sequence. So most of the rock, you can see from here, the age is about Cretaceous age, but it's exposed to the surface during Middle Miocene tectonic event. Next, okay, so for the methodology, as usual, so we go to the field, we observe the outcrop, and we collect the rock samples, we bring to the lab, and this is the method so that we are using for the laboratory analysis. We prepare the thin section to study the mineralogy of the rock and also the weather rock. And we also study, so this is XRF, to measure the major elements of the rock using X-ray fluorescence method. We also measure the mineralogy of the ultrabasic soil using X-ray diffraction, study the micromorphology using scanning electron microscope, and the concentration of the heavy metals using ICP or ES. And after that, we'll produce the geochemical distribution for the heavy metals using SURF program. Okay, so we go to the field observation. Okay, this is the typical outcrop of the basic. So this is a road cuts around Kampung Libang Ranau. Here, this is the basic outcrop. If you can focus on the hand specimen there, we can see there is a feature of fault. So you can see the silicon side and the formation of minerals on the surface, yeah, due to the low grade of metamorphism, or due to the formation of minerals, for example, the chloride, chloritoids, and some chrysotile. Okay, so this is the ultrabasic profile also. It's about less than 1 meters there, but I would like to show. So there is a fault zone there. Normally, the weathering agent will attack the fault zone or the micro crack of the rock. You can see here there is a changes of color. There is a slightly decomposed of minerals in the fault zone, and we can see also here there is the silicon side due to the movement of rock or due to the changes due to the pressure during tectonic. So you can see here the different color, different type of minerals, and the silicon size is indicator for the fault zone and the movement of the rock. You can see here also the weathered ultrabasic rock. You can see there is a fill up by silica, the late stage of magma. So this is silicification process. Silicification. So this is typical to form the quartz vein in the Ulrabasic rock in this area. So late stage. So you can see here the width of Ulrabasic rock. You can see the different color there. You see here there is a crack, so which is filled up by iron oxide due to the oxidation process. So you can see here there is iron crust. It's become accumulate in the with the Ulrabasic rock samples. And for the matured soil, Ulrabasic soil, you can see the formation of this is the concretion or earth. The iron crust here is quite hard compared to the others Ulrabasic soil here. See, so this is the concretion. So next, if you see the profile, sometimes we can see that the Ulrabasic soil is not stable in terms of the slope. So we can see there is a destroy of drainage here. See, this is due to the landslide occur. So this is the way from Ranau to the one complex on the way to pouring. So for the petrographic study, we collect the fresh samples, then produce the thin section, so we can observe from here. So this is the mineralogy of peridotite or Ulrabasic soil. Under cross polarized light, you can see the pyroxene, the olivine. See, same samples here. Yeah, the same samples. This is the olivine, the weighted olivine. And under plain polarized light, you can see there is a formation of opaque minerals. Maybe iron oxide. See, you just fill up the micro crack of the minerals. Yeah, so this is due to the oxidation process of the minerals. So for the classification based on the study, so we can classify the Ulrabasic rock as a herzolite. Right, so this is from the thin section observation. For the serpentinite rock, so some researcher study the serpentinite rock. So this is due to the metabolism process, low grade metabolism process. So whereby most of the olivine will change to the new chloride, chloritoid, or maybe this secondary minerals. So under cross polarized light here, so you can see the orthopyroxene, and so there is a crystotile also. Under cross polarized light. Beside that, we can see also the orthopyroxene, the olivine, and also we can see the opaque mineral, iron oxide or hematite in the cross polarized light. Next, for the weighted Ulrabasic rock, so we observe in the microstructure there. So this is under cross polarized light. So this is the same samples, but under plain polarized, you can see most of the crack was filled up by iron oxide here. So this is also due to the oxidation process. Okay, different samples, same can observe from here also. Yeah, so this is the crack which is filled up by microstructure. So over here also you can see the formation of iron oxide. Next, for the scanning electron microphotograph study, yeah, so nice picture here. We can observe the serpentine minerals crystalline from the surface of fresh rock samples. So you can see here the typical feature of chrysotile in ultrabasic rock. Right? And in the ultrabasic soil, so you can find the hematite, goethite, and some samples we can observe the smectite or monsmorillonite. This is come from the weathering process of plagioclase, yeah, in ultrabasic. And for the physico-chemical properties, so we managed to collect the sample from the top of the weathering profile to the bottom, and we measure the pH value, the moisture and organic. So this is two different ultrabasic profile. So this is the value for the pH, it's around 5, 4. And the moisture quite high, 29, so there is 76, and the value for organic matter. And then also this is from one paper, so they study also the optimum moisture content and also the maximum dry density of the ultrabasic soil. So this is the value you can see here. The moisture is about 32 to 44, and the maximum dry density 1.2 to 1.3 megagram per meter cube. Okay, so we go to the data for the concentration of major elements. This is for the fresh rock samples. As I mentioned just now, the silica is less than 45%. So this is the indicator for the low silica content for the ultrabasic rock here. The rest you can see from here, the composition for MgO, then followed by iron, and this is the loss of ignition for the both peridotite and serpentinite, which is around 11%. The rest is less than 5%. For example, the aluminum, yeah, the manganese, Ca, K is less than 5%. Okay, this is the X-ray diffractograms for the ultrabasic soil. See, the same profile but different horizon from the top to the bottom here. So there is no separation method here. We just collect the sample and we run through X-ray diffraction and we identify the type of minerals. So you can see from here there is goethite, hematite, and also smectite, monsmorillonite from this pattern, yeah, of X-ray diffractograms. See here. This is for the second station. So more or less same pattern we also can found there. So there is goethite, hematite, mingimite, and also the monsmorillonite in the soil samples. And so this is the data for the heavy metals concentration. So from the top to the bottom of the profile. So this is the soil samples, and this is the fresh rock samples. This is the depth from the top to the bottom. So this is the pH value, and this is the concentration for the cobalt, the chromium, copper, nickel, lead, and also zinc. So you can see from here the red color shows that there is a process of heavy metals enrichment. See, yes. For example, the nickel. So in the fresh rock, this is the concentration 3289, but the rest can achieve until 1000. And then also the chromium here, so the fresh rock, and this is in the soil. Okay, different profile, but the same elements here. This is the depth, the pH value, and so this is the concentration of heavy metals from the different horizon there. So red color shows there is an enrichment of elements. You can see from here, this is 507, so this is up to 1% concentration. Okay, so for the with the third objective of our study is to study the effect of ultrabasic rock on the environment, ultrabasic soil on the environment also. So this is the cross section from the Ranau complex there, spot complex, to the hilly area. So this is the paddy field area. So we can see around Kampung Marakau and also Kampung Libang, a different orientation of cross section cover. This is the village Kampung Tudangan, Libang, and the rest in Narut. And you can see from here. So this is the bedrock of Ranau Sport Complex and also the bedrock of Kampung Tudangan, which is built up by ultrabasic rock. So here this is sedimentary rock from Trus Muddy Formation. This is admixture from the soil from the hilly area, and also on the bottom part there is a gravel pinosoup due to the glaciation in the middle of Pleistocene age. From the mountain Kinabalu. Wow, so the view around the paddy field somewhere here. Again, close up here. Okay, so this is paddy field. So you can see the color of the sediment, which is originated from the hilly area. So the people, the farmer there, use the water for the irrigation. So this is the paddy field, left and right side there. Okay, so we collect the sample on the surface about 10 cm from the surface, and we measure the concentration of heavy metals, you see, and we plot on the geological overlap in topography map and also the geological map. So most of Kampung Tudangan here, you can see at the north east there is beneath there is ultrabasic rock. So this area mostly sedimentary rock. So this is the paddy field area. So you can see from here. So there is a different pattern of heavy metals. See, so this is the highest one, 2,200 milligram per kilogram, mostly concentrated on the Kampung Tudangan area. So this is the paddy field area. So this is the distribution for cobalt elements. You can see the next elements for the chromium. So it shows also the same pattern with the cobalt there. You can see. Here, the concentration, the high concentration sama in Kampung Libang, Tanah Merah, Kampung Tudangan, here, and it's become reduced to the southwest, Kampung Kilo, Palima, the rest. So this is for the nickel, distribution of nickel. You can see from here, same pattern, but the concentration is only up to 1800. Yeah, 18000. So we can see from here, Kampung Tudangan Libang, same pattern with cobalt and also chromium. But this is different. The lead, maybe there is different source of lead. Yeah, so Kampung Tagudon, senior to the Kampung Pinapulitan, but only up to 31 milligram per kilogram. This is not, so we conclude that this is not come from the weathered Ulrabasic. Maybe there's other source from the anthropogenic. Yeah, it's maybe due to the there is a workshop and also a motorcycle workshop there. Okay, so if we compare with the composition of heavy metals in the earth crust, see, of course, ultramafic rock shows very high composition or concentration of heavy metals compared to the others type of rock. So if we compare with basalt, granite or shale, and also in the earth crust, so ultramafic you can see is very high. So this is due to the natural process where during the formation of Ulrabasic there is a high concentration of this kind of elements in the lattice of minerals. Yeah, so this is the original process. We cannot avoid this one, but we can map the distribution, and also we can provide the information to the people surrounding area. So if you compare with the concentration of heavy metals in soil, yeah, so the red color shows there is more than I think 100 to 100 times compared to the critical soil total concentration. So there's a potential of natural pollution of chromium and also nickel in this area. See, at the basic rock in Ranau, 2768 milligram per kilogram, but for the total critical concentration, if it's achieved 100, there is potential of pollution, and also nickel over here. Okay, so yeah, so from the study we can conclude that yeah, there is a potential of a natural pollution of nickel and also chromium in the study area. Okay, so yeah, so the conclusion here, chemical weathering reaction on basic rock or ultramafic rock will alter the primary minerals or leaving pyroxene to iron oxide minerals and also clay minerals. And the combination of weathering, leaching, transportation, sedimentation process has released the heavy metals from the lattice of mineral and redistribute to the environment, yeah, into the lowland of agricultural area or into the peripheral area. So of course, the main source of heavy metals is originated from weathered ultramafic rock. Okay, so for the recommendation, so we try to study the effect of heavy metals. For example, the nickel and also chromium into the human health. So we managed to secure grant, and so for the next research, we are going to collect the specimen from the people who stay around this area. So maybe the hair or the other tissue. Then I will measure if there is potential of contamination. And the second one, so yeah, there is also potential of economic for the chromium and nickel. So we see the price of chromium and nickel now it's become increased. So I think we should study the potential, the economic potential of chromium and nickel in this area. So we can find there is a 10 meters thickness, up to 10 meters thickness of ultrabasic soil there. If any possibility to mine, so maybe we can plan, because it's a very huge area of ultrabasic soil in this area. Okay, I think before I end my presentation, I would like to analyze. So this is part of our research. So we collaborate from the team from Guangzhou Institute of Science and Technology and supported by our postgraduate students. I think that's all. Thank you very much.
Right, thank you very much, Prof. Professor Dr. Baba Musta. Now it's open to Q&A session. Any questions from the floor? Yes, please.
So, has anyone looked at the heavy metal concentration in the rice plants or in the rice itself?
Yeah, I think there is one published paper from UKM. So they collect the samples from the paddy field and measure the heavy metal in the root, seed, and also in the paddy itself. There's a pattern there. The pattern is not achieve the critical level. They still can consume the paddy, but the problem is the paddy become low productive. If you compare with the paddy who cultivate near to the ultrabasic soil, the paddy resistant to grow well. It's not. There is I don't know. There's a biological process where they cannot uptake the heavy metals, but they're stunted. You see, it's become small and low production. Yeah.
Thank you, Professor Musa. It's a very interesting talk. I'm just wondering, I have two questions. One, if I'm not mistaken, I went to Sabah back about 5-6 years ago. It seems like your Menteri Besar, your government, Chief Minister in Sabah, somehow I got the idea that he want to promote environment and somehow ban logging as well as mining. Okay, so I'm just wondering when you mentioned that you would like to see the potential for exploration. That's one thing.
Okay.
But we work on things called phytomining and remediation. So probably this is one way to keep the environment, and yet we will be able to extract valuable heavy metal from soil without open mining, because the most common methods of nickel mining, especially in Indonesia, is basically open pit, and it's quite destructive because it would take a lot of a large area of land. That's one thing. My second question is there's a term called laterites. In soil in your study area, have they become like technically laterites or not? Thank you.
Okay. Thank you, Prof. Okay, so the first question, the previous chief minister, so they have banned the mining activity because they have to fight with the environmentalists. Now, due to the economic crisis, there's a few places where we can explore the area with clean technology mining. The recent gold mine, actually in Tawau, Sabah, in Mantri, Gunung Mantri in Tawau, Sabah. They're using clean mining technology. And our new government, so now they are focusing on ex-mined tin deposit in Peninsular Malaysia as well as rare earth elements. See, so we do the mapping, geological mapping, to see which area has potential to be mined. But I'm not sure how's the extraction process. They should avoid using the hazardous chemicals. Okay, the phytoremediation. This is one method to remove the heavy metals without destroy the surface structure of the of the land. Yeah, but this is quite expensive, really. Yeah, and also the efficiency. I don't know, because we did study also the ex-copper mine there. So we plant this grass, and after the grass is matured, and we cut, and you still can remove without destroy the phytoremediation. The second question, laterite. So I measured the composition of aluminum and also the ferrous oxide in the ultrabasic soil. So this we can consider this is as a laterite soil also, based on the percentage of aluminum, silica, and also iron. So we can consider this is as a laterite soil. Laterite soil.
Okay, all right. Any more questions? Okay.
Bismillahirrahmanirrahim. Thank you, Mr. Baba. I asked a question. As a student who the first doing research. Can we get with visible eye, with naked eye, differences in weather ultrabasic rock? Differences in weather ultrabasic rock. Can we get with naked eye?
You mean ultrabasic from peridotite and serpentinite from naked eye? So if of course different. So there is a changes in terms of color. So there is oxidation process. So you can see the weathered ultrabasic rock will change to reddish color, slightly yellowish color. So this is a typical color for the ultrabasic. So this is totally different if you compare with the, for example, the sedimentary of sandstone. Sandstone is slightly white or yellowish color. So there is a difference in terms of color, in terms of course, in terms of minerals also. There is a different. See, does it answer your question?
All right. Any more questions, students? No. All right. Okay. Thank you, Professor Dr. for very interesting studies. And next.